Hi boys and girls, today we're going to be doing another spiral review, which just means we're going to be doing questions that you've learned throughout the entire year so far. They are all practice Regents questions to help you prepare for the Regents exam, okay? You really should be trying them on your own first and then checking the video to see if you got them correct and to see how to do any of the ones that you didn't know, okay? But I am going to go through every question and explain them. All right, number 1. The cost of airing a commercial on television is modeled by the function C of n equals 110n plus 900, where n is the number of times the commercial is aired. Based on this model, which statement is true? The commercial cost $0 to produce and $110 per airing up to $900. So I didn't really see anything that had to do with $0 up here, but I do know that 0 doesn't mean anything. So let's keep reading. It says $110 per airing. So I know that per means to multiply, and they're telling me that airing, the number of times a commercial aired, is represented by n. So 110n and something to do with 900, right? So 110n and 900. All right, so maybe it's 1. We don't really know yet, so let's just keep reading. The commercial costs $110 to produce, so it's 110 by itself, and $900, so end would mean plus, right? So end $900 each time it is aired. Well, each means to multiply, okay? And the number of times it's aired is represented by n. So that would mean 110 plus 900 and then times each time. So 900n. So 110 plus 900n. Well, this says the 110 is attached to the n. This says the 900 is attached to the n. I'm going to get rid of choice 2. That can't be correct. Let's look at choice 3. The commercial costs $900. I'm going to write that over here, 900, to produce, and $110. So plus $110 each, which means to multiply, time it is aired, which is n. So 900 plus 110n. 900 plus 110n. If you look up at our problem, we have 110n, 110n. We have 900 by itself, we have 900 by itself. So that is the correct answer, and let's just look at 4 just to be sure. It says the commercial cost $1,010. Well, I don't see $1,010 up here at all. I mean, if you made a silly mistake and added 900 and 110, you might get that number, but we know that we can't add those two because they're not like terms. Okay, so it can't be choice 4 either. Make sure you read through each choice carefully, just like I did, because those could get a little tricky if you don't read carefully. Number 2, the graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Which statement best describes what the jogger was doing during the 9 to 12-minute interval? I'm going to highlight that, of her jog. So between 9 and 12 minutes, well, if you look, we have the speed on the left and the time on the bottom. So when we're talking about between 9 and 12 minutes, well, this is 8 and this is 10. 9 must be in between. And then 12. So between 9 and 12. So what I'm going to do is I'm going to draw a line up to my graph. So between 9 is like little barriers. The 9 minutes and 12 minutes. This interval in between those two times is what we're talking about. They want to know what happened. Well, was she standing still? Was she increasing her speed? Was she decreasing her speed? Or was she jogging at a constant rate? Well, looking at this, it's flat, right? So if I'm looking at my choices, this says she was increasing. Well, increasing means she would have to be going up, right? Increasing means up. She's not going up at all. So I'm going to cross that out. She was decreasing her speed. That means she was getting slower. Well, it still says her speed is 6 all the way across. So she's not getting slower. That would mean her line would have to go down, or the line would have to go down. So she's not decreasing. So now I'm stuck. Was she standing still? Or was she jogging at a constant rate? When you're running and you're standing still, if you think about your speed, you're not going anywhere, right? So your speed, if you were standing still, would have to be 0 miles per hour. Well, up here, can't be 0 miles per hour because that would mean it would have to be all the way at the bottom. Okay, it is at 6. So at the 9-minute interval, a 9-minute time, she's at 6, and she stays at 6 for 10 minutes, 11 minutes, 12 minutes. She stays at 6 that entire time. So because it's the same speed, that means it's a constant rate. So I'm just going to put over here, same speed. So she wasn't at 0 miles per hour. That means she would be standing still and not moving at all. She was moving. She was just at 6 miles per hour the entire time. So she was at a constant rate, same speed, which in this case was 6 miles per hour. Number 3, which table represents a function? That's a key word, so I'm going to box it. Okay, when we think back to functions, a lot of us answer and say, oh, that means something can't repeat, right? But we have to be very specific, okay? Especially when we're talking about tables. The function means that the x values can't repeat, cannot repeat. Okay, we have to remember that the x values cannot repeat. So let's just look at our tables. Well, we're going to focus on the x values. We're going to focus on these, and these. And those only. So we're only focusing on the pink right now. So let's look at choice 1. I have a 2, a 4, a 2, and a 4. Well, the 2's repeat, and the 4's repeat. So it's a lot of repeating. I want them not to repeat, so let's get rid of choice 1. Looking down to choice 2, I have 0, -1, 0, 1. I see a 0 and a 0. That means they repeat. Can't be choice 2. Looking up at choice 3, I have a 3, a 5, a 7, a 9. Again, I'm ignoring the y values. Just looking at the pink, the x values. 3, 5, 7, 9. Those are all different numbers. None of them repeat. So I think that's going to be my answer. Let's just double check. The 4th choice. 0, 1, -1, 0. I have a 0 and a 0 that repeat. It can't be choice 4. Okay, so function means the x values cannot repeat. Next page. Which inequality is represented in the graph below? We talked about this on the last spiral review packet. When I'm looking at this graph and then I look at all my choices, okay, I see some similarities, right? Like this has -4x minus 3, -4x minus 3, and then this has -3x plus 4, -3x plus 4. The thing that changes are the signs. Okay, so let's just focus on the signs right now, the symbols. Okay, these symbols and these graphs, there's like 2 things that we want to focus on. Whether or not it's a solid or a dotted line. So this graph, it is a solid line. And whether or not we shade above or below. So in this case, if you put your pen or pencil on the line and you follow the shading, it goes up above the line. So this is being shaded above. Okay, whenever it's a solid line, it means that it can be less than or equal to and greater than or equal to. As soon as those equal to lines, those pieces underneath, are included, it's a solid line. Okay, well, let's look at our choices. All of those have that line at the bottom. Okay, so let's keep going. Now it says that shading above. Well, if I'm shading above, that means the symbol has to be greater than. And that symbol looks like this. So if it's a solid line and it's greater than, so greater than or equal to, well, let's look at our choices and get rid of anything that's not greater than or equal to. Well, this is greater than or equal to, so I'm going to keep that. This is less than or equal to. I want to get rid of that. Let's look at this. This is greater than or equal to. I want to keep that. This is less than or equal to. I want to get rid of that. So now I'm stuck between 1 and 3. So at this point, I got to decide, is it -3x plus 4 or -4x minus 3? 2 ways you can do this. You can either type it in the calculator, each one, and see if the points match up. Okay, that could be an easy way to check. Or you can look at this point up here. Okay, this, when it crosses the y-axis, it's called the y-intercept. Well, that y-intercept is +4. So my y-intercept in my equation or my inequality should be the one that's by itself. Okay, that +4. But let's say I couldn't remember that. I wasn't sure of that rule. Let's just go in the calculator and check. Y equals, I'm going to type in negative 3x plus 4. And I'm going to go to my table. And I'm just going to see if these points match. Well, this point up here is 0, 4. Well, this says 0, 4. The next point says 1, 1. Well, if I look on my graph, positive 1, positive 1. That's there. 2, negative 2. If I look at positive 2, negative 2. That's there. So I would say that is the correct one. If you check this in the calculator, you'll notice that the points don't match. So just real quick. It says 0, negative 3, right? So this would be your y-intercept on choice 3. But I don't have a point at 0, negative 3. I only have a point at 0, positive 4. So choice 1 is correct. Number 5. What are the zeros? That's a keyword, so I'm going to highlight it. What are the zeros of the function f of x equals x squared minus 13x minus 30? So, I mean, to find the zeros, you could try to factor. There's a bunch of different things you could try to do, but since it's multiple choice, I want to use the calculator. I want to make it as simple as possible. So I know that this f of x can change to a y equals. I'm just going to rewrite it as y equals, and then I'm going to go to my calculator. They want to know, let's just type it in first, x squared minus 13x minus 30, and I'm going to go to my table. Okay, what we want to find out is the zeros. So let's just put in calculator. And we want to look for when the y is 0. But they give you choices. They give you x values to work with. So let's just go choice by choice. Choice 1 says negative 10 and positive 3. So those are my x values. I'm looking to see if at negative 10 is my y going to be 0. So let's scroll up to negative 10 in our calculators. Negative 10 on my calculator says 200 is the y value. So right away, negative 10 doesn't work, so I'm going to get rid of choice 1. Let's look at choice 2. It says positive 10. I'm going to scroll down to positive 10. It says negative 60. I want it to be 0, so that can't be correct either. Looking over at choice 3. It says negative 15. I'm going to scroll up to negative 15. Negative 15 says 390, so it can't be that choice either. Let's check choice 4, positive 15 and a negative 2. Well, if I look at my negative 2, well, that worked. It's a negative 2, 0. And let's double check the positive 15 because they both have to work. Positive 15 is also 0, so that works. So this choice 4 is the correct answer because when I went in the table, 15 as an x value had a 0 as a y value, and negative 2 as an x value had 0 as a y value. Number 6. Alex is selling tickets to a school play. An adult ticket costs $6.50, and a student ticket cost $4. So before moving any further, I'm just going to write that down. Let's write ourselves a little note. An adult ticket is $6.50, and a student ticket was $4. All right, let's keep reading. Alex is selling X adult tickets and 12 student tickets. So let's write that down. $6.50 was adult, and he's selling X adult tickets. $4 was student, and he's selling 12 student tickets. let's see what the question asks now. It says, write a function f of x. So because they tell you to write a function f of x, you must use f of x. So I'm going to start and write f of x equals before anything else. They want us to write a function f of x to represent how much money Alex collected from selling tickets. Okay, so I have f of x equals $6.50. And now with these two, it didn't say that I was adding them together. I'm going to be multiplying them together. So $6.50 times X amount of tickets. And then I have $4 for student tickets. And it's 12 student tickets. So I'm going to be multiplying the $6.50 and the X. And the $4 I'm going to multiply to the 12. Now they want to know how much money he collected from selling tickets all together. So I'm going to have to combine those adult tickets and those student tickets by adding them together. Okay, so this was... So I can leave my answer like this, but in order to simplify it a little bit better, I'm going to rewrite it. F of x equals $6.50 x plus, because I can simplify this 4 times 12. 4 times 12 is 48. I just took it one step further to simplify it. But this is what they're looking for. They're looking for a function that can represent how much money Alex collected from selling tickets. Okay, and that's adult tickets and student tickets all together. The next page. Last 2 questions for this packet. If the difference 3x squared minus 2x plus 5, all in parentheses, minus x squared plus 3x minus 2, is multiplied, another keyword, by 1/2 x squared, what is the result written in standard form? So let's look at difference first. It says if the difference means to subtract. So I'm going to write my 2 steps here. I'm going to have to subtract. And then it says multiplied over here. So then I'm eventually going to have to multiply. Let's start off with the difference first. I'm going to write 3x squared minus 2x plus 5. In parentheses, minus, just rewriting it, x squared plus 3x minus 2. When I have this minus in between the 2 sets of parentheses, that really means there's a -1 there. Okay, if I have nothing in front, that means it's a +1. Okay, and anytime I multiply 1 times anything, that stays the same, right? So this whole piece right here can stay exactly the same, and we can just drop the parentheses. So I'm just rewriting this left side. But this right side over here, this -1 needs to be distributed. So this -1 needs to be multiplied. -1 times x squared, -1x squared. -1 times a +3, x is a -3x. -1 times a -2 is a +2. Now I need to make this a little bit neater and combine like terms. So if I combine like terms here, I'm looking for the same variable and the same exponent. So I have a 3x squared and a -1x squared. Those match each other. So 3x squared minus 1x squared. But I'm combining like terms. Okay, 3 minus 1 is 2. Variables and exponents stay the same when I am just combining like terms. So 3x squared minus 1x squared is 2x squared. Then I see that -2x matches with -3x. -2 minus 3 is -5. Variable and exponents stay the same. Then I have a +5 and a +2. That becomes a +7. Okay, I did my difference, but I didn't do my multiplication yet. So now I need to do my step 2, which is multiply. They said multiply the difference. Well, we just found the difference. Multiply that by 1/2 x squared. So I'm going to rewrite this all in parentheses. And I'm going to multiply that by 1/2 x squared. So I'm going to put that on the outside of the parentheses. When it's on the outside of the parentheses, that means I'm going to distribute. So this 1/2 squared, x squared, is going to be multiplied. So all 3 terms. So up here, we kept the variable and the exponent the same because we were just combining like terms. Now we're multiplying. So we're going to take the coefficients. 1/2 times 2 becomes 1. X squared times an x squared becomes x to the 4th because we have to add the exponents when we are multiplying. So now I'm going to do 1/2 times -5 becomes a -2.5. X squared times x. This is really an imaginary 1, so it becomes x to the 3rd because I added the 2 and the 1 as the exponents. And this last piece, 1/2 x squared times a +7 becomes a +3.5, and I can't forget about this x squared. Now let's just go back to the question. They want to know what is the result. So I subtracted, I did my difference, then I did my multiplication. So we found the result, but they want it written in standard form. So let's just check. Standard form means the exponents go from greatest to least. Well, I started out with an exponent of 4, then the next piece is 3, then the next piece is 2. So the exponents do decrease from greatest to least, so I'm good. If they didn't, you would have to reorganize it so that they were in order from greatest to least. Okay, so this would be my final answer for question number 7. Number 8, determine the smallest integer, that makes -3x plus 7 minus 5x is less than 15. True. So let's write this out again. -3x plus 7 minus 5x is less than 15. Well, in order to find out if something is true for it, I need to solve it. So I'm going to draw my train tracks down from my inequality symbol. The whole left side, I can clean that up. There's some like terms that I can combine. So this -3x, you should notice that you can combine that with the -5x. -3 plus a -5 is a -8x. Bring down your +7 that we didn't use yet. Bring down your 15 on the other side. Now, it's really just solving just like we solve equations. -7, inverse operations. Bring down the -8x. 15 minus 7 is a +8. Still don't have x alone yet. I need to divide this -8 out. Divide on both sides. Bring this cancels. Bring down my x. 8 divided by a -8 is -1. Now I need to focus on my symbol. This symbol up here, I need to decide, well, is it going to change or is it going to stay the same? My only rule is that if I divide it by a negative, it's going to change. Well, I divided by a negative because I divided by that -8. So I need to flip the symbol. This, instead of less than, just flips, it becomes a greater than. Now, a common mistake is that we stop there because we think we're done, we solved it. But if you look back at the question, it says determine the smallest integer that makes that true. So this is where I need to start making a list. So it says x is greater than -1. So numbers that are greater than -1, if I start to go in order, the next number bigger than -1 is 0. Then 1, then 2, then 3, right? And so on. So out of that list, my smallest integer that is greater than -1 is 0. This is the smallest integer that makes this true. 0 is greater than -1. So my last little thing, I have to actually write it out as a sentence. So 0 is the smallest integer. And that is it, okay? Okay, that is it. We'll see you on the next video.